Welcome to flow rate measurement devices. We are going to study Orifice Plate, which is pretty similar to that one on Venturi Tube, but the idea is to have a very drastic change on diameter. So actually you put the pipeline here and this will be the small one, and then you calculate the differential. So as you can see, you have the flow, normal flow, you install this Orifice Plate with small diameter, and you will have this jet or beam right here. So similar to Venturi Tube, we're going to do a analysis or balance on mechanical energy. Let's use this equation, and yeah, let's solve it for the Orifice Plate. There's no change on height, no pump, no workout. There is of course friction, but we're going to use a coefficient to add that friction, so forget about that. And well, actually that's everything. And remember that we can relate velocity of A with respect of B if we have the diameters, which I think is pretty common to have in the industry. Okay, that's what I told you, and remember the continuity equation. This is A, this is the velocity of A, the diameter of A, this is the diameter of B, velocity of B. So from the past equation, you just need to solve for B, for the throat. So you pass this one, you will get delta P divided by rho minus, where is it, velocity divided by 2, solve for B right here. Solving for velocity, you will get this equation. Don't forget to plug in this right here. So we don't need to find the velocity, we just need to find the diameters. And yeah, we're done once again. It's similar to the Venturi Tube. Actually, we're going to use a correction factor because I told you there's no friction. But as you can see, there's obviously friction because you are having a sudden contraction. So the coefficient, the correction factor will change, but the most normal value is about 60 or something like that. You are going to check this out depending on the value of beta. Okay, yeah, okay, perfect. Now let's make an analysis. We have this diameter and we have this small diameter, and this goes the flow and so on. Don't forget always that the diameter of the pipe is this one and the diameter of the orifice is this one right here. Now many times you want to know the friction loss in terms of joules per kilogram, and we can do it very easily knowing the ratio of diameter. So if we have a ratio of 0.5, you go here and find out that you have a 0.78 with respect of the delta P rho. So you need to calculate the delta P and divide it by rho and then multiply by this, and this is your friction loss. Okay. Actually, because I am so geek, I did a function, so I got random points on that equation and then apply an equation which is probably right here. Yeah, it's here. So I could use it in a Excel or even in my calculator. You want the equation is here. Y is the friction loss with respect of delta P divided by rho. The beta is essentially just the diameter ratios. Okay, you have it right there. You can plug it into Excel or anything like that and it will work. But before advancing to a exercise, I want to show you the advantages on the orifice plate. So the good thing is that it's very easy to change the plate orifice. So because they are plates placed in a pipeline, you can change it and then you bring another plate. Oops, this is Spanish. Relatively easy to install, easy to move between pipelines, and you don't need that much space. So as you can see, let me go back. It's right here, it's not that much. You can see this is the plate, right here is small, versus the Venturi Tube, which was a little bit more, let's say, bigger. And disadvantages is the high operation cost, because as you can see, there's a lot of friction being lost right here. It's not the same having a very smooth transformation. Here we have a very drastic change that will of course increase the energy loss, and if you have a high energy loss you will have a high operation cost. And not only that, you also have a pressure loss which you will need to recover with a pump. So not only that, you need to install a pump to recover that. Of course in the Venturi Tube you need to do it as well, but this is more critical. And let's do exercise number 8.4 for Orifice Plate. This was a free preview. You want to get full access, go to my incompressible flow course. The link is in the description of the video. You will get all access. Not only that, you get a very straightforward, user-friendly interface. So for instance, if you were analyzing or studying pumps, you have it here, the pump block, then you have the sections. If you were, for example, studying the types of pumps, you can go here, and you have all the classes right here. Not to mention that you also have introduction and conclusion of every one of these. So for instance, if you were studying positive displacement pumps, the video is right here. If you were studying positive displacement pumps in rotatory and reciprocal are also included here. Centrifugal pumps, which is a very important topic in this course, you have it right here.